Alright, it seems like everything's working now, okay. Alright, so what are the questions that people have right now for the assignment, or whatever? Alright, so there's a question in Twitch chat that says, can you quickly show how to send data over a socket? Yes. Let me see, which level is it that sends data over a socket? Level 8, okay. Is this the Unix socket or the TCP socket? Alright, looks like it's the Unix socket. Let me see, I think Netcat can do it. Yeah, Unix domain socket. Okay, so if we run, actually let me put this into Teambox. That way I can do it from a separate terminal. Launch the challenge. Tells us, of course, which the path to that Unix socket is. So I guess it's probably a little more common to see TCP sockets being used for applications. So things definitely do use Unix sockets. And I guess in my mind, besides the underlying protocol being different, right, TCP, I actually don't know entirely how the Unix socket implemented under the hood. But regardless, there is a file associated with it, rather than just like going at some port and your operating system figuring out how to talk to that port. There's an actual backing file. So for instance, Docker actually uses a Unix socket for communicating with the Docker daemon, but so some things do use Unix sockets. So anyways, if I wanted to talk to this thing, this is probably a way to do it. So if I say hello world, and then Control D or Control C, let's see if it got our input. Looks like I got our input. Where did it? Oh, it skipped bytes though. Hold on, let's try that again. Okay, so we just send a bunch of random bytes, and we can see it gets picked up here. So Netcat is definitely a nice and simple way to talk to sockets. You can of course use Python instead, and if you read the documentation on the sockets library on how you can connect to a Unix socket, if you'd rather do it with Python, you can check that out. Okay, so another question in Twitch chat. I have written the disassembler for level 14. I think the next thing to do is understand what those instructions do, but it is difficult to figure that out. Is there a way we can decompile the assembly automatically? I'm going to say definitely not automatically. At least I don't know of any tools that would be able to decompile an arbitrary architecture. So the way these decompilers normally work is they either just understand x86 and all the semantics associated with it and have various heuristics and capabilities for lifting that into some C-like language, or more commonly, especially nowadays, is that they use an intermediate language. So for instance, Anger uses an intermediate language called VexIR. Binary Ninja has its own actually several IRs, binary, like they have their medium level IL, and I use IL and IR pretty interchangeably. I don't know if there's actually a difference between the two. But basically the short answer is no, you can't just decompile it. So how many, let's see here. I think realistically the best thing to do would probably just be kind of go through it instruction by instruction until you know what's going on. Of course, similar though to normal reverse engineering, kind of there's more interesting instructions to especially be looking at. So for instance, while reverse engineering, right, you use strace to see all of the syscalls happening. And I think it would probably be useful to especially focus in on those syscall instructions happening. That being said, you'll probably have to understand all of the instructions involved, but I don't think it's too many. I think it's, if I remember right, the VM only supports up to like 256 instructions, so yeah, I'd probably stick to that. Alternatively, I guess you could probably build up an understanding of what the VM state is, and then maybe you can just like skip through several instructions and then just look at what the current state of what the virtual machine is. I believe level 14 in particular eventually, right, just like hangs. If we strace it, I assume it's hanging on like a read. Yeah, so somehow through whatever code the VM's calling it's taking in read. So for instance, if I send it like ABC, oh, I'm still in tmux, hold on. Oh, maybe I'm not. Scroll. Let me reset this. Is it not letting me scroll? Hold on. Let me just, for now, use tmux and let me copy over this tmux config file. Okay, good enough. Okay, so anyways, what we were looking at was abrev. If I type like abc, obviously we know eventually it's going to come back and say incorrect. But saw somewhere it branched. Read memory. Okay, so it takes in our ABC. So for instance, something you, in theory, could do to speed things along, potentially, I don't know this for sure, potentially you could just like skip everything that happens before this read, say who cares, it's taking in my data, figure out what the current state of the VM is, figure out what it's doing with your data to make it say incorrect, and figure out if there's a different path to make it not say incorrect, and presumably that path will be the path that gives you the flag. But yeah, I mean, ultimately you're going to have to be reading through instructions to understand. So this jump, jump E. So presumably it's comparing your string. Go back to the ABC. So we can see it does these STK operations. Who knows what those do? I'm just kind of like high level, like looking at this. I honestly don't know what the STK instruction does. I assume stores probably or something. I don't know. You'd have to reverse the VM, of course, to understand that. IMM, I think, as we discussed in my previous office hours, seemed to be an immediate instruction where it's just storing a value. It looks like we're storing some 6.2, and the interesting thing to note with hex 6.2 is that that is ASCII. So that could be relevant, that might not be relevant. I keep seeing my. Hold on, let me run through this again, but with T. Temp output. We'll do ABC again. Okay. Temp output. ABC. Oh, not gonna. Capture it. Did. Oh no, maybe it didn't. I'm in right. I'm in less within tmux, which makes things weird. So I know at some point. Actually, we can just hit Shift G to go to the bottom. Hit Control P to go up. Let's see here. So unfortunately, this probably, I'm 99% sure it didn't capture our ABC that we typed in. Taken, not taken, that's not about where we were. We have a compare. It. Actually, hold on. Rather than doing this insane method, let's quickly. Okay, so it said read memory. That's right. Okay, so that's what we want to search for. It's read memory. Okay. Okay, so it does these STK operations, and then it does immediate D equals hex 6.2, which is ASCII. Of course, might not be relevant. Who knows? Looks like it might not be because then it goes on to do something that isn't ASCII. But okay, so that means the store memory star C equals D, so we're at A4 is the value 6.2. Okay, so maybe it is relevant because this is just an address, whereas this is a potential ASCII value. Then hex 7.7, the ASCII as well. And then they use A again, hex 40. Not storing this time. Okay, so this is pushed onto the stack. Okay, so SDK likely stands for stack. Something like that because it says pushing D. And then it starts adding stuff. We're looking for a compare instruction because that is the most relevant instruction in terms of if you want to compare against what we just input. At some point, you're going to have to do some sort of comparison on it. Okay, so compare AB. Unfortunately, now we're like several instructions in. We'd have to like backtrack through what this A is referring to and what this B is referring to. See how this compare instruction proceeds. Though I guess, no, because we don't see memory currently, so we can't actually look at registers. Oh no, but this is loading from memory, right. Okay, so we can see that A becomes 0 and B becomes hex 4A, which is ASCII and is possibly one of the characters I entered. That, I guess, for so in order to more easily reverse this, would have been nice if I would have just like sent a bunch of A's. Then we'd be able to see if this B register is now looking at one of those A's. See if we're comparing against like 0, for instance. But I mean, either way, I'm going to continue on to the next question. This is an approach that kind of works for teaching, the teaching level. But of course, when you're on level 14 in the testing level, you said you already have a disassembler, right? All I'm looking at is effectively, okay, so I guess I'm looking at disassemblers, and then I'm also looking at part of the internal state of the VM, at least for the registers. So essentially something you might want to do is also write an emulator for level 14. Not necessary, of course, but potentially it'd be useful. And then basically for the testing, you'd have the same output as the teaching. I'd be able to see the instruction running, be able to see all of the values of the register after that instruction runs. And potentially your emulator could also print out values in memory. And then, I mean, kind of as I've been doing for the last like 5-10 minutes, you just kind of read through these instructions and look for high-level important parts, I guess, where important means like basically syscalls and compares. Like those are absolutely critical. Like control flow and like interacting with the environment. Those are like basically what a program is in some sense. Okay, so let's see what other questions there are. I've hit a big wall on level 14 right now. I think once I get the teaching done, I should be able to pull off till level 16 testing. Yeah, that sounds believable. I don't completely remember off the top of my head the difference between 14 and 15. I think 16 ends up having you write instructions for this VM. And then 17 and 18 get a little, but you'll be able to continue to use your disassembler and such also for 17 and 18. It's just there will be more to the story. Okay, so in Zoom, there is a question that says, so for 14, you want to enter in your string at the read part. When you say printing out values in memory, isn't that what A, B, C, D, S, L, F is doing? Okay, so all of these things right here, so A, B, C, D seem to be general purpose registers. S is likely some sort of stack register. So I'm just going off guess here. I honestly don't know how it's implemented. But when I start seeing like these star A's and like LDM sounds like load memory, it makes me believe that there's more than just a bunch of registers, that there's probably some section of memory as well, beyond the registers. So it looks like, based off of just like thinking through other architectures like x86, that there's A, B, C, D, probably general purpose registers. S sounds like stack, I sounds like instruction pointer, F sounds like flags. In fact, with this F being flags, we can see before it's like these zeros. And then after we do this compare instruction, it becomes 0x6. So yeah, it seems pretty likely that that's a flags register. But yeah, there's more to the internal state of the VM than just the registers, likely. It seems like there's some sort of stack and some sort of maybe general memory region. Potentially the two are in the same spot. Who knows? Maybe there's just a stack, or maybe there's just a group of memory, or maybe they're overlapping, maybe they're not. But there is more, it seems, to this VM's internal state that might be worth emulating or looking through in GDB or whatever. Tips on, actually, hold on. Expected result for level 4 testing is not a valid hex value. Don't, that question means you'd have to rephrase it. Tips on utilizing the ability to change offsets in levels 11 through 13. So in my previous office hours, I talked about levels 11 through 13. I don't actually know if I put that on YouTube yet. At a minimum, it's currently sitting in a Twitch VOD on this channel, and I'll make sure it gets pushed to YouTube. But in that, I talked about figuring out where that offset maps to in memory. And I think in my example, I basically changed a byte to be hex CC, where hex CC is interrupt 3, which does a sig trap. So in my example, I think we were able to change 5 bytes because I was on level 11. And after changing the first byte, the program immediately sig trapped, which means I was controlling basically the code, right? I was changing the actual running assembly. So if you think back to baby shell and baby jail of writing code, so like the idea of shell coding. In this case, right, you only have 5 bytes to work through, so you're probably not going to be able to just put in some arbitrary shell code. But you can change the code that's already there to make the code do what you want. And think of this in the context, we call this like a cracking level, right? Think of like if you were to crack some program and it was doing like a license verification check, what you would be doing is basically hijacking the control flow of the program to skip over that verification check. And that's exactly what you can do here. You can just, I think we call MD5 on your input and then compare. You're not going to break the MD5. Why not just skip the MD5? That's something to think about. Yep. Oh, there's a question in. Yep. Go for it. Yeah. So let me. I guess I can do it from here. Objdump -d -m until. This whole not scrolling thing is gonna ruin this. Let me see if I can fix that real quick. Can't even copy this. Maybe I can. Alright, 1 second. Let me this real quick. Then terminal again, and hopefully now it won't be broken. That'd be great. Okay. See if I can scroll now. Oh, thank God we can scroll again. Okay. Oops. Okay, so we were doing objdump -d -m intel challenges baby rev level 11 teaching 1. Okay. And of course you can look at this in Binary Ninja or Ghidra or whatever tool you want to look at. Right now, since I just have my terminal being captured and I don't want to figure out how to make my browser be captured or something else, we're just going to look at it in objdump, which works perfectly fine. Okay, so as was discussed in my previous office hours, we found these 2 scanf instructions. And if you remember, this level asks you to input in hex a offset and then asks you to input in hex a value. It's very likely and reasonable to believe that that would be implemented by 2 back-to-back scanfs, and in fact, as we figured out in office hours last time, it was. So this is checking for your offset, this is checking for your value. And then this right here, as we discussed in the previous office hours, we're moving a single byte into memory after doing these 2 scanfs. That's a pretty good sign that that single byte is going to be the value that we just constructed and then going to the offset. So in office hours last time, and I think it's worth watching the video if you guys are working on levels 11 through 13 and a little stuck. In office hours last time, we basically made it so that this instruction, rather than doing what it normally does and then getting ready to loop to ask us to change another value, instead became an int 3 and just did a sig trap immediately. So we modified this to sig trap. Obviously that's not useful for getting the flag, but what is useful is basically just figuring out how to divert your code to so all of this MD5 stuff, we don't care about this. Ideally what you'd like to do is just kind of like jump to here, for instance, right? This is going to do a call. Actually, you probably need to go like here. Oh, like jump here. because this is going to load in flag, it's going to open flag, it's going to send file flag. So if you, instead of doing an int3, for instance, just like jump here, right, just skip all this code that you don't care about, that would be a much easier way. I mean, or that would be an approach, right, to solving this level. In this case, you have 5 bytes to work with. You can probably very likely figure out how to just literally jump there. In level 12, you only have 1 byte to work with, and then in level 13, I think you have 2 bytes to work with, but 13 also has another little twist. And in that case, you probably won't be able to figure out how to do a jump in just 1 byte. But remember that one of the high-level concepts, right, of a program is its control flow graph, and basically all of the paths it's going to take. And similar to how I was talking about level 14 before, like what really ultimately matters in a lot of senses is the compare instructions and the syscalls. If you can flip a byte to change control flow, like that would potentially have the same effect. Okay, more questions. Let's see here. Yay, so we briefly went over 14 at the beginning of this office hours. I'll go over it more if you have a more particular question, but let me quickly answer these other questions. So think of like a particular question you're interested in for 14. Okay, so how can we use GDB with certain things like netcat and FIFOs? Okay, so when you are running GDB, yeah, I guess we can demo it here. Hopefully running tmux doesn't destroy my ability to scroll again, as you said. Okay, so if I run, let's just say level 14 because it takes an input. Actually, and let's do it in GDB. Yeah, whatever. Okay, so we start, we're in GDB, we're executing level 14. At some point it's going to take input, and it's going to look basically exactly the same for a FIFO or a netcat or whatever, based on how I show you this. We hit continue, and eventually it's asking us to input. It's hung right now on a read instruction. Fact, let me scroll up so I know dev pts 7. Okay, so if I now go, kind of guessing this will work, I'm not entirely sure, dev pts 7, if I now echo bunch of random stuff, actually, yeah, we'll just do random stuff, to dev pts 7, you could think of this, instead of being dev pts 7, it being like a FIFO or a really whatever, or a netcat. You could be netcatting instead of echoing at this. And then I hit enter. I think what we'll see didn't work. I had to hit enter. So I am using, not Jeff, I'm using pwn.debug with a configuration where basically if I type, I don't know if this will work in Jeff, it might just be, I think it's just a pwn.debug thing. If I do, oh no, it's not running. Type start. If I do proc info, you can see that the standard in for this program is dev pts 7. So I'm basically just demoing the idea, and I guess it's not actually working because PTS is a little weird. Demoing the idea that you can just start talking like to a file or a socket or whatever outside of GDB. If you use tmux, for instance, you can just switch to a different terminal. And in the case of like the FIFO levels, eventually you'll see a file appear here, and you can just echo at it and then switch back to GDB. It looks like talking straight to dev pts 7 isn't working. Yeah. I don't know. Yeah, pseudo terminals are a little weird, so you can't necessarily just talk straight to them, but you can definitely talk straight to the FIFOs and sockets. Actually, I could probably show that. Let's see here. If I make FIFO temp FIFO, what? Oh. Okay. Assume I can write to that still, because I own it. Oh yeah, of course I can. And then I do GDB baby rev level 14, and if I now do start with temp FIFO, so that is now my standard input. And then I do proc info proc. Is that immediately? Hold on. Echo test temp. Oh. Yeah, it immediately exited. But either way, as I'm showing, you can do it that way. Just switch to a different terminal using tmux, or just on your computer open another terminal SSH again, and just talk to it from the other terminal. Just fine. Okay, what other question? Let's see here. Once we get all of the VM code bytes assembled into proper instructions, what do you recommend doing next? I completed 1 through 13 primarily through Ghidra C interpretation. The list of assembly instructions is pretty overwhelming. So I would say there's only 8 instructions, right, in this language, in this architecture. If you look into like Intel, there's hundreds of instructions. So I would, I guess, recommend just fighting through that overwhelming sensation, right? You're only looking at a couple hundred instructions, where each of those instructions can only be like one of 8, plus obviously different operand values, but the instructions themselves, there's like 8 instructions. Each instruction is fairly simple, I would say. Like, it's just like storing stuff in memory, loading an immediate into a register, etc., doing a syscall. So yeah, I would recommend just kind of fighting the overwhelming urge and I guess forcing yourself to deal with it and learn. That's pretty much my best answer to that. I was never able to figure out level 3 testing. It seemed pretty easy to me, but the solution is not working. Is there some trick I'm missing to that? I guess there's a number of places you could have gone wrong. I guess the first thing to make sure is that you're inputting the value correctly. So make sure you're not getting like an assertion error or whatever. Another thing to make sure of from there, I guess, would be just walk through it in GDB and see where your assumptions about level 3 are going wrong. And I think Jan has talked about it in his office hours, and I've talked, yeah, especially, probably Jan's office hours would be the best to watch on going through levels 1 through 10 and just kind of stepping through it in GDB and seeing what's actually happening. That would be the best way to figure out where you're going wrong. Okay. Are there more questions? Yep. Okay, so the question was about level 7, using Ghidra and the file descriptor being some large-ish hex value. I think Jan, when did he demo this? I think he demoed it yesterday, or I guess it would have been Wednesday, at the end. Did you watch, so if you were, did you go into the breakout rooms on Wednesday? Yeah, I guess that's what I meant actually. So while you guys were doing that, Jan was still answering questions from Twitch chat or whatever on the lecture video. So it'd be worth going back and looking at that. He shows what it looks like. He basically goes straight over level 7. And he shows in GDB a good way to, instead of looking at some large file descriptor value, instead looking at inputting it through standard in for reversing purposes in GDB. And then he also shows redirecting to some arbitrary file descriptor on the terminal. So actually I could probably show that pretty do cat proc self fd, or I guess it'd be ls. So normally you can look at your own process, see your file descriptors. This is in this case what we have. And then of course you can redirect to an arbitrary file descriptor. So in this case we'll go 1, 2, 3, 4, and we'll just redirect dev null. And now you can see an open file descriptor in this process is 1, 2, 3, 4, and it's pointing at dev null. So using this syntax, you can actually redirect to an arbitrary file descriptor. So if you think back to, what would it have been, Baby Jail, I think there was a level that kind of expected you to just suddenly have, or there's one of the solutions to that Baby Jail level was having a file descriptor already loaded into the process, like inherited from its parent. So this syntax in Bash makes it so so Bash is of course spinning up bin.ls, a new child process for Bash, and it's making it inherit dev null at file descriptor 1. In fact, let's see how easy it is to confirm that. Just completely. Let's. That let's temp out 3, 4. Yeah. Okay. So this is still gonna be. It's going super clean. Look at this. Okay. So. Yeah. Okay. So we can see. Is it open? Okay, so we can see here that Bash does an open at of. Okay, yeah, this makes sense. I think the scrolling was because tmux is scrolling and not less. So we can see here that Bash, which is of course, the program running that's interpreting our whatever commands, at some point, because of our syntax, decides to open dev null. The next available file descriptor is 3, that's fine. We told Bash that we want that to be on file descriptor 1, 2, 3, 4. So Bash uses dupe2 to take the previous result because it doesn't have control over this ending up on 3, it just has to end up on 3. But it can decide now to make 3 also be 1, 2, 3, 4. So now 1, 2, 3, 4, and 3 are both pointing at dev null. Bash doesn't care about file descriptor 3 anymore, so it just closes it. And then it runs user bin ls, and user bin ls will end up inheriting these file descriptors. So it'll inherit the 1, 2, 3, 4 file descriptor. So kind of at an in-depth level, that's why this works. But syntax-wise, this is especially this end part, is the syntax for redirecting to a descriptor. So hopefully that'll help you with level 7. But if you're still confused, Jan had a very good discussion about level 7 at the end of Wednesday's extended Q&A. Okay, so more questions. Let's see here. Are more challenges going to be added? Not this week. So more challenges for the next module will be added on Wednesday. And I believe that will be going into memory corruption. What tips would you give for starting to write an emulator? I have the disassembler done, but I am lost on what to do with creating an emulator. So I don't actually, I know I talked about an emulator at the beginning of the class. I'm not sure. It kind of depends whether or not you think it's useful. It will take a bit of work to write an emulator. Basically, you need to make it so, I mean, effectively what you would be doing when you write an emulator is rewriting the challenge in Python or something. So you'd have to implement the 8 instructions. You'd have to implement the semantics of those 8 instructions. In order to do so, you'll have to also be able to represent the state of the VM. The state of the VM we know definitely has these registers. So it looks like there's 4 general purpose registers, a stack register, an instruction pointer register, and a flags register. It seems to also have a bit of memory dedicated to a stack, and also have a bit of memory dedicated, I guess it would have a bit of memory dedicated to where the instructions themselves live, and a bit of memory dedicated for just general scratch memory use or whatever. So basically you would go through obj dump. If I leave tmux, is my scrolling still messed up? That's not sweet. If I do this, ab rev that, okay. So basically what you would be doing, and yeah, it's really up to you to decide whether or not it's worth it for you to do this. In my opinion, probably not, but on the other hand, maybe it's useful, I don't know. But if you wanted to write an emulator, this would be way easier to look at in Binary Ninja. But we will use object dump because why not? Make it difficult. You would basically have to go through and convert all of these all these functions for interpreting an instruction into Python. So yeah, you'd be re-implementing the VM in Python or whatever language you're familiar with, and then you'd be able to execute the instructions in that. Obviously, this might be a little insane, because it definitely sounds a little insane. So it might actually be easier instead to use some sort of GDB scripting, and just use this already implemented VM kind of as your emulator. And at that point, I mean, I guess you're using GDB, understand what the instructions are doing where you're lost. So let's see here. So if I do, does this show me? Yes, it does. So we have all of these interpret functions. We have our interpreter loop. Have these functions. Actually, is it always the T? I don't actually remember what these things stand for. T. Looks like it. Okay, so let's do grep space T space. And that still has some, obviously that stuff we don't care about. So something you could potentially do is write a GDB script that breaks on every single one of these functions here. Actually, you probably don't necessarily care about main, and maybe you don't care about interpreter loop because I think that'll just be called once. But you could add a breakpoint to every single one of these functions and just print out what's happening as you care about it. So let's see here. Let's go to tmux. Gonna let me copy, is it because of tmux? See, I'm not very good with tmux, I don't really use it. I just use Emacs, and Emacs does everything. So I don't normally use Emacs this in a terminal like this. But let's see if we can make this work. So we want to go to home. Let's write a GDB script. So let's call it emu.gdb for emulate. Okay. So what do we want this thing to do? Actually, let's also do the same thing we did here, but in a way that I can actually copy it within the confines of Emacs. So let's do that, grep t that. Okay. We care about the following functions, approximately. So we care about these things. Yeah, we'll leave interpreter loop. Why not? Probably doesn't matter though. So if we have this script, actually before we do it, let's switch back. Let's get ready to start running GDB in this way. And actually, do I want to be using own debug? Probably not. Actually, I think GDB has a batch mode thing. Is that GDB-Q? Man GDB-Q. Let's search for batch. It's just dash batch. Is that gonna make it like not be annoying? Let's see. GDB-batch. Maybe. That briefly did a tmux thing, didn't it? It's kind of annoying. Alright, let's quickly just disable our GDB init. Because we don't actually care about any of this stuff. It's not gonna, I have it symling. Okay, there's another easy way to do this, and that would be to move GDB init to GDB init stop. Okay, now if I run GDB, it is running the default version of GDB. Okay, we don't care about this anymore. Okay, and then if we do GDB baby rev and we do -x, do our emu.gdb. Why is it like not? Okay, didn't do anything, but it didn't complain, so that's a good start. So what if we type in start, because that's the first command we want GDB to execute. It started it, so that's awesome. Okay, so now what we want to do is break on every single one of these. So I'm going to get ready to do insane Emacs stuff in order to make this much easier to write. So I'm going to create a macro. I'm going to say break crash. And then we are going to do that. Do printf crash end, and we will just make it read that. Okay, I don't know if the syntax is entirely right, but we can fix it if it's not. We probably wanted to continue, but fix that. Okay, so what happens now? This command cannot be used. Oh, I think I also did it wrong. I think you do break, crash, and then you do commands. I think that's good. Okay, so we'll go there, type that. Oh, I didn't type commands, did I? Place string, command, commands. Okay. Okay, so it sets a bunch of breakpoints for us. And then if we type continue, we hit our interpreter loop breakpoints, we hit our interpret instruction, interpret immediate, blah, 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 blah. Okay, and what we want to do here is instead of this, let's make it so it also now continues. This is why Emacs, oh god, I'm not going to say that I messed it up. This is why Emacs is amazing. What is happening now? Okay, there we go. This is why Emacs is amazing. You just write a sweet macro and cool stuff happens and you don't have to keep writing code. So why would you want to do that? Why is it not continuing though? Is that not saved? Saved. Yes. All of those. Continues. I don't think that's going to make a difference. Well, let's see if it does. Oh, it did. Wait, maybe? Yeah, it did. How do I disable this? I know Jan showed in his GDB how to disable this. I don't remember what it is though. Hold on, maybe if I go into batch mode it just won't matter. Let's see. What? Does it not like actually do the printfs in batch mode? Oh, but I didn't type continue at the start. Maybe if I put a continue right away, or I guess after we create all these breakpoints, maybe batch mode will. Let's see. Did I type batch mode? I did not. Okay, sweet. But I still have to press enter, didn't I? Why do I have to press enter? Let's see here. Let me quickly Google. Don't press enter. Set pagination off. Okay. Let's try that. GDB init. See, this one will be empty now. It's fine. Oh, that did not copy. There we go. Okay. Let's try that now. Still don't know. What if I don't do batch mode now? Still hanging on something. Oh, it's hanging on us asking for our input. Okay, now that makes sense. Never mind. Okay. So we can do batch mode as we'd wanted. Not actually be in a GDB shell. All we care about is running this. Okay, so the reason I was so confused about this stopping is that it's stopping when it's asking us to actually input what we wanted to input. Okay, so now there's tons of stuff on the screen that we're not really interested in. So let's change all of these printfs to do something that we can grep against. So printf, and we'll do that. Yeah, I think that will work just fine. Oh, that. We want to replace printf with printf. Okay. Oh, we didn't get our space. That's gonna bother me. Hold on. Replace string printf that. Okay. So now if we go to GDB again and we grep against that little identifier we made for ourselves. Oh, of course, right. The original VM also used that little plus thing. Okay, whatever. We'll pick our own unique thing. Replace string that with that. So I'm imagining we're on like testing mode or whatever, where we don't have these nice things. Okay. What? Just happened? Oh, we're grepping against the. Oh, I think the plus was unique. I see the issue. Okay, so the plus was unique. The issue is that we're not printfing with a new line. Replace string. This is gonna be. How do I do this? If I end with double quotes Alt J for a new line. So if I end with quotes new line, then I want /n quotes new line. Okay. That didn't quite work. Okay. If I have that to be only 4. Okay. Just happened. Oh, plus. Something tells me that grep is interpreting these. So I just need to do that. Yeah, okay, sweet, there we go. Okay, so imagine we're on testing mode now. We're getting closer and closer to turning testing mode into teaching mode. So now the thing that we're interested in is what are the arguments. So, and this is going to take some reverse engineering to see what's relevant, but I guess at a minimum we can start by printing RDI. In fact, we're probably not going to want these new lines right away. After we added them, let's get rid of them. Instead, okay, so instead let's do p/x RDI. Yeah, why not? Cool. And now, actually, we're also going to want to just printf a new line. Printf new. Okay. How does that look now? Okay, we're getting there. It'd be kind of nice if it didn't store it into a variable like this. How can I... What are the odds that printf will somehow be able to accept RDA as an argument? That'd be pretty cool. Let's see. Rather than change them all, describe register. Let's just change describe register. Describe register. Okay, so there's a chance this will work. I don't really know. We do that. RDI like that. Does that work? It really worked. No. How can I print it? Alright, more Googling. GDB print register without signing. Maybe I should just search for printf register. GDB. Wait, people say this does work. Is it not working? I mean, people are showing %s. Obviously, we're not string register. Let's try it. Describe register. Oops. No. But people, if I to an int, good measure, we'll just wrap another one. And it's %x. If not, we will give up on this dream and have, okay, whatever. Okay, so instead, let's just do let's do the original print RDI, and we'll just make sure that there's a space. This kind of is lame. There's probably a way to do it, I'm sure, but I don't want to invest too much time figuring that out. So if we replace string again with that, Alt J, replace it with space, Alt J. Now, of course, oh, now, we can fix that. Replace string with that. Okay, and then the final thing to do is replace 5 spaces with 4 spaces. I don't know why it's adding an extra space. Okay. So now we at least have a space between when it shows us that annoying like assignment thing or whatever. But we can see now values getting passed. And you can imagine, I'm not going to keep doing this so I can get some more questions. You can imagine you can just keep instrumenting more and more stuff into your script. You can start printing more register values that are getting printed to these things. So for instance, actually real quick, let's go ahead and confirm. For instance, in the case of describe register, it seems like that 0x20 is probably the 0x20 register that we're getting ready to describe. Yeah. So let's do obj dump. Describe register. What we're interested in though is someone calling describe register, so we can see how many arguments are being passed. This doesn't work. Okay. So what are people passing? So they pass RDI in. Okay, so it looks like describe register probably just takes one argument. The return value seems like it doesn't matter because no one's doing anything. Oh no, someone does something with arguments here. Okay. So we're definitely taking in RDI or EDI in this case. And no one's passing into RSI, so it seems like describe register probably just takes one argument. Actually, describe register. So let's see. What does it do? Call anything. So it's probably looking straight at our state. And it would probably be reasonable to guess that our state is a global variable. That's going to be coming some state come. So we have a bunch of compares. The describe register plus hex 96 is coming up a lot. So where is that? See that that is going to 1331. Okay, so that's just going to pop RB. Oh, so that's leaving. Okay. Oh, they're loading something into RAX, right? Okay. Oh, okay. So we can see here that we're comparing EAX against who knows where that's coming from. But basically, what we're going to end up doing is after that compare instruction, we're just going to rapidly try to just leave the function. And if we fail to do that, we're going to load RAX up with a different value, and then we're going to try to leave the function. So, second. That button. Okay. So yeah, this is pulling from RIP plus 1D, 1F. It's probably from our state. Yeah, you'd have to keep reverse engineering this. Yeah. Okay, so is there any more questions though? Basically, if you instead of writing an emulator, I would highly recommend instead writing a GDB script, because basically the emulator is already written for you, right? That's what the challenge VM is. Alternatively, if you find it easier to just think about it in Python or whatever, you can write it. There's only 8 instructions that you have to implement and a few things to represent the state. But otherwise, yeah, GDB scripting, whatever you're interested in, I would start printing values about the VM state. So presumably there's some global variable somewhere that just holds up like all of the values of the registers. There's probably something that also points to the memory of the VM, probably something that points to all the instructions of the VM. And whatever you're interested in seeing at whatever point, you just like print that all out and just now you have a dynamic analysis for seeing stuff. Are there any more questions though before I begin to wrap up this office hours? All right, it seems like there are no more questions. Oh, yep, you have a question, all right. I will definitely be available over the weekend to answer questions. Yeah, so if you have any questions, feel free to either email us or message me on Discord or whatever, yeah. Yeah, so the first thing is that there's like 200 or 100 or however many instructions loaded in. That you would need, you first want to be able to disassemble them and kind of understand what each instruction is doing. And this is a little bit of a tedious process. And then the more tedious process, though, is kind of going through instruction by instruction, understanding how it's altering the state. At some point, it's going to read in some data from you. It's probably doing like, at some point, maybe it's mangling it or not mangling it, doing a comparison. Somehow it's going to compare it, and then eventually it's going to attempt to give you the flag, it seems. And you just have to kind of go through the slightly tedious process of figuring that out. Yeah, unfortunately, there's not much of a better approach. We tried to make some of these things as simple as possible to make it less tedious, but still convey the idea of reverse engineering. But unfortunately, reverse engineering is just a very tedious process. Yeah. And then it looks like someone has a question in Twitch chat. And one of the questions, why are people asking questions from? Yeah, so this is a class at ASU, and we have a Zoom call as well for people in the class to ask questions. But you're feel free to ask also in Twitch if you have a question. I will wait a little bit to see if you do have a question. Otherwise, I will be wrapping up this office hours. Alright, well I will sit in Twitch chat for like 5 minutes. I'm going to end everything, and if you have a question I will answer you in Twitch chat. So let me